Hello PCB developers and learners. Welcome back to PCB Hub. In today's video, we're going to discuss 10 PCB layout mistakes that every designer should avoid to prevent costly PCB respins and manufacturing issues. Whether you're a student, electronics engineer, or PCB designer, this video will help you understand common layout mistakes, improve first-pass manufacturing success, and avoid unnecessary redesigns. Most respins happen because of simple mistakes missed during reviews. So let's get started. One of the most common reasons for PCB respins is using incorrect footprints. A mismatch between the component package and PCB footprint can cause assembly failures, soldering issues, and expensive redesigns. Always verify footprints against the latest manufacturer datasheet. Even a small deviation in pad size or pitch can render an entire batch of boards unusable. Fixed components such as connectors, displays, switches, antennas, and mounting holes should always be placed according to the mechanical drawing. Incorrect placement can cause enclosure fitment issues. Remember, these components often bridge the electrical and mechanical worlds. A single millimeter of offset can mean the board won't fit its housing, leading to an immediate respin. Trace widths, spacing rules, differential pair constraints, impedance requirements, and drill sizes must be defined before routing begins. Incorrect constraints often lead to manufacturing and signal integrity issues. Always check your constraint settings before you release the design. Automating these checks through DRC is your first line of defense against human error during the routing phase. Every signal needs a return current path. Routing high-speed signals without a continuous reference plane can increase EMI and degrade signal integrity. Always provide an uninterrupted reference plane beneath critical signals. Without a proper return path, your signals will find their own way back, often creating noise and crosstalk that can be incredibly difficult to debug after manufacturing. Placing components in height-restricted areas can create mechanical conflicts with enclosures, shields, and heat sinks. Always review component heights before finalizing the layout. Don't just think in 2D. 3D DRC checks are essential to ensure that your tallest components, like electrolytic capacitors or large inductors, have the clearance they need. Incorrect solder mask and paste mask settings can lead to assembly defects such as solder bridges, insufficient solder joints, and exposed copper. Carefully review mask layers before release. Review your mask openings pad by pad, especially for fine pitch components. A small error in the mask expansion can lead to short circuits that are hard to rework. When pads connect directly to large copper areas, soldering becomes difficult because heat is absorbed by the copper plane. Thermal reliefs improve solderability and assembly reliability. Without thermal reliefs, you risk tombstoning or cold solder joints because the heat is sucked away from the pad too quickly during the reflow process. A PCB may look fully routed but still contain open connections. Always perform connectivity verification and review open net reports before generating manufacturing outputs. It sounds simple, but you'd be surprised how often a single, almost connected net slips through. A final connectivity check is non-negotiable. Mounting holes may be plated or non-plated depending on grounding requirements. Incorrect mounting hole definitions can lead to manufacturing and assembly issues. Verify if your mounting holes need to be tied to chassis ground. A mistake here can lead to EMI failures or even mechanical stresses that crack the board. Even a perfect layout can fail if manufacturing information is incomplete. Always verify fabrication notes, stack-up details, drill tables, copper weights, and impedance requirements. Your final review is the last gate. Check every fabrication note to ensure the manufacturer has exactly what they need to build your board right the first time. By avoiding these 10 common PCB layout mistakes, you can significantly reduce PCB respins, improve manufacturing success, and save both time and cost. A thorough design review is one of the most valuable steps in the process. If you found this video helpful, please like, share, and subscribe to PCB Hub. Design, learn, innovate. Thank you for watching, and I'll see you in the next video.